Good morning, guys. So, our topic for today is all about the principles of hydrostatics. So, for our objectives, first is to understand and master the following topics. So, first is the unit pressure or pressure, then next is the Pascal's law, then next is the absolute and gauge pressures, then next is the variations in pressure, and last is the manometer. So for our first topic is all about the unit pressure or pressure. So pressure is the force per unit area exerted by a liquid or a gas on a body or surface, with the force acting at right angles to the surface uniformly in all directions. So we all know that the pressure is equivalent to force divided by the area. So in the English system, pressure is usually measured in pounds per square inch or also known as the PSI. In international usage in kilograms per square centimeters or in atmospheres, and in the International Metric System or SI in newtons per square meters or also known as the Pascal. The unit atmosphere ATM is defined as a pressure of 1.03323 kg per centimeter squared or equivalent to 14.696 pound per square inches, which in terms of the conventional mercury barometer corresponds to 760 millimeter, or equivalent to 29.921 of mercury. The unit kilopascal kPa is defined as pressure of 0.0102 kg per square centimeters, or equivalent to 0.145 pound per square inch. So, yeah. Then for the Pascal's law developed by French mathematician Blaise Pascal states that the pressure in a fluid is equivalent in all directions and in all parts of the container. In figure 2-1, so as you can see in the figure, as liquid flows into the large container, at the bottom, pressure pushes the liquid equally up into the tubes above the container. The liquid rises to the same level in all of the tubes regardless of the shape or angle of the tube. So the laws of fluid mechanics are observable in many everyday situations. For example, one good example is the pressure exerted by water at the bottom of a pond will be the same as the pressure exerted by water at the bottom of a much narrower pipe, provided depth remains constant. So if parehas lang yung depth niya, so parehas lang yung kanyang pressure. So if a longer pipe filled with water is tilted so that it reaches a maximum height of 15 meters, its water will exert the same pressure as the other examples. So fluids can flow up as well as down in devices such as siphons. So one good example of siphons, so search natin. So siphons. So ano ba yung ating siphons? So ito yung example of siphon. So hydrostatic force causes water into the siphon to flow up and over the edge until the bucket is empty or suction is broken. A siphon is particularly used for emptying containers that should not be tipped. So ayan. So hinihigop niya yung fluid sa isang container to the other container. So ayan. Then next, going back, next is the absolute and gauge pressures. So we have also discussed the absolute and gauge pressures from our past topics from the properties of fluids. So gauge pressure or relative pressure are pressures above or below the atmosphere and can be measured by pressure or gauges or manometers. So here is an example of a manometer and here is the example of gauges. Atmospheric pressure and vacuum is the pressure at any one point on the Earth's surface from the weight of the air above it. A vacuum is a space that has all matter removed from it. It is impossible to create a perfect vacuum in the laboratory no matter how advanced a vacuum system is. Some molecules are always present in the vacuum area. So that is an example of the atmospheric pressure or also known as the vacuum. Then for the absolute pressure is the pressure between above absolute zero or also vacuum. So for our formula for absolute, so P absolute is equivalent to P gauge plus P atmospheric. So if P atmospheric is not given, automatic, the value of P atmospheric is equivalent to 101.325 kilopascal or kilonewton per square meters. So note, absolute zero is attained if all air is removed. It is the lowest possible pressure attainable. Then next, absolute pressure can never be negative. Kindly take note of this one. So can never be negative. The smallest gauge pressure is equivalent to the negative of the ambient atmospheric pressure. Then for the mercury barometer, a mercury barometer is an accurate and relatively simple way to measure changes in atmospheric pressure. At sea level, the weight of the atmosphere forces mercury 760 mm, equivalent to 29.9 inches, up a calibrated glass tube. So higher elevations yield lower readings because the atmosphere is less dense there and the thinner air exerts less pressure on the mercury. So higher elevations daw have lower readings because the atmosphere is less dense. Ayan, can you take note of that? Then aneroid barometer. So in an aneroid barometer, a partially evacuated metal drum expands or contracts in responses to changes in air pressure. A series of levers and springs translates the up and down movement of the drum up into the circular motion of the pointers along the aneroid barometer's face. So here is an example of the aneroid barometer. Then next, so for the variations in pressure, so consider any 2 points 1 and 2. So point 1, so here is a point 1 and point 2. Whose difference in elevation is h. So difference in elevation, so itong h. So to lie in the ends of an elementary prism having a cross-sectional area A. So cross-sectional area natin, so ito yan, A. And length of L. So length ng L natin is ito. Since the prism is at rest, all forces acting upon it must be in equilibrium. So with reference to the figure, so we all know that weight is equivalent to unit weight times the volume, where volume is equivalent to A times L, or length times the area. So by using the equations in equilibrium, so summation of forces along x tayo equals 0. So F2, so papunta sa kanan, which is positive, minus F1 equivalent to, so ito, kunin natin yung x neto, x value, equivalent to W sine of theta. So W sine of theta yung value neto at along x-axis. So simplifying the equation, so input natin yung value ng W. So ayan, AL sine theta. So simplifying, so ang formula natin will be P2 minus P1 is equivalent to gamma H. So, ayan yung formula natin for variations in pressure. Also, so, P2 is equivalent to P1 plus WH. So, mangyayari yan kung this means that any change in pressure at point 1 will cause an equal change at point 2. Therefore, a pressure applied at any point in a liquid at rest is transmitted equally and undiminished to every point in the liquid. So, kapag ganito yung nangyayari, so ang formula natin is P2 equivalent to P1 plus WH. So let us assume that point 1 in figure lying on the free liquid surface, then the gauge pressure P1 is 0. So yung kapag meron tayong free surface, so sa ano natin, fluid natin, kapag hindi siya closed, so ang pressure natin doon is 0. So I take note yan. So kapag wala na tayong P1, so ang formula natin is P equivalent to WH. So this means that the pressure at any point H below a free liquid surface is equivalent to the product of the unit weight of the liquid gamma and H. Ayan. Then next, so consider the points 1 and 2 in figure lie on the same elevation such that H is equivalent to 0. So kapag wala daw tayong difference in elevation, so kapag pahalang lang yung ating material, sabi shape. Kapag ganito lang daw yung ating material, so lie on the same surface. This means that the pressure along the same horizontal plane in a homogeneous fluid at rest are equal. So P1 is equivalent to P2. So parehas lang sila ng pressure. Then next, so pressure below layers of different liquids. So consider the tank shown to be filled with liquids of different densities and with air at the top. So meron tayong air at the top under a gauge pressure of PA. So ayan. The pressure at the bottom of the tank is equivalent to. So ganito lang yan. Summation lang natin yan. So P bottom, yung pressure daw sa bottom, since meron tayong gauge pressure dito, is equivalent to gamma H plus P. So ayan lang yung formula natin. So kapag sinimplify natin yan, so unit weight na ito times H3, so ito yan, plus unit weight na itong liquid 2 times H2, ito yan. So H2 daw, gamma to. And unit weight na ito, liquid 1 times H1, ito yan. So ayan yung, so pag tinotan mo yan, yun na yung pressure at the bottom. So pressure head is the height of each of a column of homogeneous liquid of unit weight gamma that will produce an intensity of pressure P. So formula natin for pressure head is P divided by gamma. So pressure head is a height. Then next, so to convert pressure head height of liquid A to liquid B, so formula natin, so HB, example, we have HB equivalent to HA times specific gravity of A divided by specific gravity of B, or HB is equivalent to HA, unit weight of A divided by unit weight of B, or HB is equivalent to HA times rho A divided by rho B. Then to convert pressure head height of any liquid to water, just multiply its height by its specific gravity. So H water is equivalent to H liquid times S liquid. So ayan. Then next, so punta tayo sa manometer. Wait, kuha lang tayo ng tubig. Water. So a manometer is a tube usually bent in a form of a U, containing a liquid of known specific gravity, the surface of which moves proportionally to changes of pressure. It is used to measure pressure. So yung manometer, ginagamit natin yan to determine for the pressure. So ayan. So here is an example of a manometer. So ayan. Then next, so for the types of manometer, we have 3 types of manometer. So that we use in the laboratory. So open type has an atmospheric surface in one leg and is capable of measuring gauge pressures. So ano ba yung open type? So ito yung open type manometer. Then differential type without an atmospheric surface and capable of measuring only difference at pressure. So in difference at pressure, so ito yung type of differential type of manometer. So determine natin yung different ano ba yung dine-determine natin dito? Yung difference in pressure. So, ayan. Kunin natin H1 dito and H2. Then, for the piezometer, the simplest form of open manometer, it is a tube tapped into a wall of container or conduit for the purpose of measuring pressure. So, the fluid in the container or conduit rises in this tube to form a free surface. So, here is a piezometer tube. So, for the limitations of piezometer, so large pressures in the lighter liquids require long tubes. So, gas pressures cannot be measured because gas cannot form a free surface. Then next. So, for the steps in solving manometer problems. So, we have 4 steps. First is decide on the fluid in feet or meter, of which the heads are to be expressed, so water is most advisable. Then, starting from an endpoint, number in order the interface of different liquids. Then next, identify points of equal pressure, taking into account that for a homogeneous fluid at rest, the pressure along the same horizontal plane are equal. Then next, label these points with the same number. Then proceed from level to level, adding if going down or subtracting if going up pressure heads as the elevation decreases or increases, respectively with due regard for the specific gravity of the liquids. So, ayan yung steps natin in solving manometer problems. So, example problem number 1 tayo. So, dito na tayo mag-answer. So, solution. So, if a depth of liquid of 1 liter causes a pressure of 7 kilopascal, what is the specific gravity of the liquid? So, given, so we have a pressure equivalent to 7 kilopascal. Then next, so ano pa yung given natin? So, meron tayong depth equivalent to 1 meter. So, ang determine natin is the specific gravity, S. So, formula natin, so solution, so formula natin, P is equivalent to gamma, or unit weight na lang, sulat natin. Unit weight times height. So, ayan. So, given yung ating pressure, so given to, then unit weight natin, given din naman, since diba unit weight natin is 9.821 times the specific gravity, times H is given. So, ang unknown na lang natin is specific gravity. So, type na natin. So, 7 kilonewton per square meters is equivalent to unit weight. So, unit weight natin is 9.81 kilonewton per cubic meters times specific gravity niya. So, specific gravity na hinahanap natin of the liquid, so S times the depth, which is 1 meter. So, ayan. So, ilan yung ating value for S. So, ito, transpose mo lang yan dito sa baba, then ito sa baba din. So, 7 divided by, try natin kung may cycle sana. Scientific calculator. Ayan. So, ano ba? So, 7 divided by 9.81. So, ang specific gravity natin is equivalent to 0.714. So, unitless yan. Ito na yung ating specific gravity. So, and that's all for problem number 1. So, punta tayo sa problem number 2. So, if the pressure 23 meter below a liquid is 338.445 kilopascal, determine its unit weight, mass density, and specific gravity, S. So, ayan. So, given. So, ano daw i-determine natin? So, meron daw tayo pressure equivalent to 338.445 kilonewton per square meters. Then, ang depth daw natin, so H is equivalent to 23 meters. Tama? Yung pinapahanap sa atin, unang-una is the unit weight. So, unit weight na tayo. So, unit weight. So, P is equivalent to unit weight gamma times height. So, ayan. So, P natin is 338.445 kN per meter squared times or equals unit weight natin is 9.81 since ang sabi naman, ano ba sabi? Walang sinabi kung anong type of liquid. No? So, anong type of liquid? So, unit weight lang hanapin natin. So, unit weight, so ito ni times height, so 23 meters. So, ilan yung ating value for unit weight? So, unit weight natin, so 338.445 divided by 23. Yan yun. 338.445 divided by 23. So, unit weight natin is 14.715 kilonewton per cubic meters. So, ito na yung ating unit weight. Then next, so B. So, B. Ako napalitan. B. So, determine the mass density. So, diba? So, for the mass density, so, ang formula natin for mass density is rho equivalent to unit weight divided by acceleration due to gravity. So, simply unit weight, so 14.715 kilonewton per cubic meters divided by the gravity, so 9.81 meter per second squared. So ilan na yung ating value for rho? So 14.715 divided by 9.81, so 1.5. 1.5. So check natin yung unit. So, meter per second squared. So, ito dapat times na lang natin siya sa 1,000. So, 1.5 times 1,000. So, 1.5 kilogram per cubic meters. Kasi naka-kilonewton pa kanina, dapat maging newtons muna. So, ayan. So, ito na yung ating raw body. Then, C. So, C na tayo. So, for C, determine the specific gravity. So, for the specific gravity, formula natin is S liquid divided by, or hindi pala S liquid kasi specific gravity na, raw liquid divided by raw water. So, mass density of liquid divided by mass density of water. So, mass density of liquid, ilan ba? 1.5 kilogram per cubic meters. So, ayan. Divided by, so, yung sa water, ilan ba sa water? Yung water, always 1,000 kilogram per cubic meter. So, ilan natin mass density? Or specific gravity. Specific gravity is simply 1.5. So, ayan. So, ayan na yung ating mass, or I mean specific gravity. So, that's all for problem number 2. Then, for problem number 3, so if the pressure in the airspace above 1 OR is S equivalent to 0.75, surface in a closed tank. So, meron daw tayong closed tank is 115 kilopascal absolute. What is the gauge pressure 2 meter below the surface? So, ayan. So, determine muna natin yung pressure surface, no? Given, we have given, so S is equivalent to 0.75. Then, sunod, we have a pressure absolute equivalent to 115 kilopascal or kilonewton per square meters. Then next. So, formula natin, di ba? Solution tayo. P absolute is equals P gauge plus P atmospheric. So, ayan. So, absolute, meron tayong value for absolute. Then, P atmospheric, meron din tayo niyan. So, P atmospheric equivalent to 101.325 kilonewton per meter squared. So, kunin natin P surface. So, P surface is equivalent to, so, P absolute natin, so, 115. So, P surface natin is also the P gauge, ha? Equivalent din to sa P gauge. P absolute, so, ito yan. So, transpose na natin P atmospheric dito. So, P gauge, 115 kilonewton per square meters minus 101.825 kilonewton per square meter. So, ilan yung ating P gauge or P surface? So, 115 minus 101.325. So, 13.675 kilonewton per square meters. Yung ating P gauge. P gauge to gauge. Then next, so to determine for the gauge pressure, so pressure is equivalent to, so P gauge plus gamma or unit weight times height or gamma H. So P gauge, so 13.675 kilonewton per square meters times or plus unit weight. So unit weight natin is 9.81 times, so meron specific gravity which is an oil, so 0.75 times height. So height is 2 meters. So ilan yung ating pressure? So pressure natin 1365 plus 9.81 times 9.81 times -0.5 times 2. So pressure natin is equivalent to 28.39 kilonewton per square meters or kilo Pascal. So, ayan. So, ito na yung ating pressure below 2 meter of surface. So, that's all muna for today. So, continue na lang natin yung ibang problems next meeting. So, ayan. Principles of hydrostatics. So, thank you for watching.